networked robotics, and we had done telepresence robotics. We hadn't done, cloud-connected robots at scale. So Roomba 980 was our first cloud-connected robot, and it was launching in 2015. Now, a couple of years prior, we had selected a turnkey IoT solutions provider to support that. And so they provided the connectivity, they provided firmware update delivery, and some scripting capabilities on it. And but even before launch, it had become clear that A, they weren't going to scale to the volumes that we needed, because we're already selling lots of Roombas. They were just not connected yet. So it wasn't a question of how many we'd sell. It's how fast is the ramp going to be from 0 to all of the robots that we're selling being connected. And then also, it wasn't extensible in the way that we needed it to be. Right? It'd be hard to do an Alexa integration on that platform. So we knew that we wanted to move off that provider and onto somebody else. And we also knew by that time that being an integral part of the smart home was part of our strategy. We wanted to own more of our own destiny in that cloud application, to be able to do the kind of extensible things that we wanted to do. So we determined that our connectivity provider was going to be AWS IoT, and that we're going to build on AWS the application behind it. And this was 2015. Lambda had just been launched the year previous. And we looked at the set of AWS services that were available and said, we don't have experience building scalable, elastic cloud applications. So we would have to learn this to scale very quickly to Roomba volumes. That's really hard. But maybe we can do this without ever having to learn that. And so we went all in on serverless. We went serverless native. We haven't ever had to run, a VM or container-based solution at scale. And that's been really successful. So I want to tell you how successful it is. If I can change the slide. And tell you about Christmas Day 2018. So it's been in production for a couple of years at this point. And the thing you have to understand about Christmas Day is, so we sell millions of robots a year. And as a lot of consumer goods companies, a lot of that business happens in the holiday season, right? So all the robots that we're selling between Black Friday and Christmas come online in about a 4-hour window on Christmas morning. And this is what the traffic looks like. Now, this is registrations per day. You can see there's, Black Friday's out over here, and there's some bump there, and the baseline goes up a little bit. Now, the daily registration rate is about 20x in this graph. Fortunately, by the time that I generated this graph, we had lost, we had cycled out the hourly data. But so that 20x is compressed into about this 4-hour window. So it's roughly 100x. It's a really, really massive spike of traffic. And here's what that day is like. We have a couple of people who do monitoring for us, and we had one employee who is tasked with taking any action. And the only thing he had to do was upshard the Kinesis stream that fills our data lake. Right? Our employees are at home with their families, and they're like on Slack because it's fun to see the numbers come in, not because they're worried about whether it's going to scale or not. Right? And we spend December building features to ship in January, rather than preparing for Christmas Day operations. And so that's the dream, right? Like, all of this just kind of works. Now, of course, it's a little more complicated than that. Christmas Day 2017, our first Christmas, also went fine. There's a few more things to do, but we didn't have the trust in the platform that we had by the end of the second year, because it was our first time. So the things that we see with this is that our operations scale with features and not traffic. Right? For Christmas this year, we're still not worried. We've got a lot more robots. In the intervening time, basically all the, like if you go on iRobot.com, you can't buy a Roomba that doesn't have the capability for a Wi-Fi connection. right? Whereas, you know, earlier Christmases, there's a lot more of that volume that we're selling that's not yet. We have small, lean teams, right? Our operations team has so little operations work to do. There's a couple of them, and they do software development work for another team in their spare time because maintaining this serverless system doesn't take up all their time. And it means that our developers are focusing on business value, right? That not only in the sense of what they're thinking about, what they're engaging with, what they're building is based around customer-facing features and not enabling platforms that would enable another team to develop those, right? All the developers are directly working on customer impactful things. But also that being serverless, literally the code that they're writing in our Lambda functions is just business logic. There's very little, you know, undifferentiated heavy lifting that we're writing code for. We're just wiring services together to deliver features. So as I said, building trust in the platform is a journey. It's not a destination, right? Building trust in AWS as as a partner in this, right? So sure, AWS is a vendor and we are our client, but when you're serverless native, the amount of your business that you're entrusting to that vendor changes the nature of the relationship. If it's not viewed as a partnership, you're not going to be able to build the level of trust that you need to be confident in these systems, to really enable yourself to let go of those operations, of those technologies, to focus on building business value. But that means, you know, there's a trust but verify aspect in here of knowing how to understand whether the platforms you're building on are working well. And then there's, when you're serverless native, you're always looking for better ways to build these things. And so staying current is important, but also staying pragmatic. So I'll dive into those things. I don't have a clock or a counter. Let me see. Sure. Just let me know at every 10 minutes, I guess. Well, just like, yeah. So we sell millions of robots per year. We've got lots of Lambda functions. So in that sort of OLTP in our front end that deals with our connected robots and apps, there's about 100 or so Lambda functions. And we use, depending on how you count, over 30 different AWS services to deliver that. None of those are unmanaged EC2 instances or unmanaged containers. We use a little bit of AWS Batch for analytics processing workloads. And I've heard we've got like an ECS task that runs longer, that we built before step functions was available, to do like one very particular thing. But none of that is in the hot path for data, right? None of that needs auto scaling. None of that needs really any operations work to help it along. We've got lots of accounts, and this is a good idea. Once you get beyond, you know, some low double-digit number of accounts, you start having to figure out how to stamp them out, and it just becomes a non-issue. You have as many accounts as you want, and it provides you, you know, security blast radius. It provides you with operational blast radius. We like to give every developer their own account. I don't recommend provisioning an account for an individual developer that's assigned sort of on a one-to-one basis. What we do is we sort of create 10, 20, 30 accounts, and then just hand that to a team to say, do with these whatever you want. You've all got access to all of the accounts. You can figure it out, keep a wiki for who's in what, so you can collaborate, but also not step on each other's toes. And then they can reuse them, because today, you know, scrubbing out an account or deleting an account are both headaches. So you sort of push that problem onto the users of the account. We do about 2,000 Lambda deploys per day. So that's not 2,000 feature deploys. but we exercise the create function, update function code quite a lot. And again, there's just, a couple of people that do operations for all of this. All just kind of runs itself. Or rather, AWS runs it for us. So this is kind of what things look like for us. This is how the app gets permissions to talk to the robot through the cloud. And you don't really need to know the details here. The point is there's some API gateway, there's some SQS, there's some Lambdas, there's some IoT rules. AWS IoT Core is sort of the crux of our system in the OLTP thing. We use CloudWatch for everything. We recently moved off of Sumo Logic and into CloudWatch Logs Insights, which is a great deal for the money. Yeah, DynamoDB. Almost all of our state gets stored in DynamoDB, Elasticsearch. But we find that all of these pieces require the least amount of maintenance. Similarly, we are working with AWS RoboMaker to manage simulation jobs. We use step functions to manage that. So when a robot developer opens a pull request, right? We want to make sure that that code is doing well. And so instead of running physical robots to test that, which we do also, we spin up simulation environments to test all of that. And managing 40 of jobs all at the same time is a great use case for step functions. So if you're interested in details about step functions, go into it. But the point is that this is a great way of serverlessly managing your state, right? It's even less to manage than Lambda if you can help. So now moving to serverless is a bit like when you go from on-prem to the cloud, right? Sure, it's less operations. Sometimes serverless gets talked about as no ops, which is just not true. There's still things you need to do, and there's new things that you need to do that don't exist beforehand. So like when you move to the cloud, sure, everything's easier. But there's some new things that you now have to do that you didn't have to do when you're on-prem, right? A lot around making sure that the provider is healthy. One of the things here is that being clear that there's still this work is really important in serverless because you need to set the expectations for what people are going to have about what work you need to do on that platform. Similarly about that while you're outsourcing the operations, essentially, you're not outsourcing, it's the responsibility, not the accountability, right? If there's an outage, we're still down to our customers. We own that, right? But even though there's not necessarily anything we can do about it. Now, the reason for that is if we were running it ourselves, sure, we could maybe fix it, but our outages would be more often and worse. And so it's valuable in the total cost of ownership to do this, even though you don't fully control your own data. Now, what we've found is when you're serverless, essentially, you're always using the production version of the services that you're using. So in that developer sandbox, when they do create function, that's against the production version of Lambda. It's not against, development version of Lambda. And so now you have a system where a lot of what's happening in your system for your customers is reliant on systems that you're also exercising in your dev sandboxes with a lot more churn. So more often in AWS do incidents affect the control plane than the data plane. So it's often like, well, you can't create new things, pushing that. But old things continue to work. I don't know why that is, but it seems to be the way it is. And so when you're having that exercise in your developer sandboxes, you often see issues there before they affect production. And so making sure that your observability, your security, both CloudTrail and CloudWatch, that you're seeing that across your suite of accounts and environments so that you can see that. Now, account limits, they've recently launched service quota, which allows you to see your limits. Those are ones, again, the more isolated that you have your systems by account, even if you run into an account limit, one thing is not going to hose another through hitting that account limit. So that's a useful reason to have many accounts. So now we have, so again, building trust in the platform is extremely important. We have enterprise support, and I highly recommend it. It's worth the money. It gives you a much more firm foundation on which to build that relationship and build that trust. You have, a team of people that you're working with on an ongoing basis. And you don't start from a position of trust, right? And that's something you can recognize, and that doesn't mean that that's not what you're trying to get to. Right? Understanding that you're not going to start with trust, but that doesn't mean it's going to go badly, only you're not sure that it will go right. Now, over time, because trust is a journey, it will fluctuate, right? It's never going to be smooth sailing all the time, but understanding, both setting expectations internally, because the first time that you have an outage that's caused by a service you're relying on, somebody's going to say, well, we shouldn't rely on that service anymore, right? We should do that in-house. And making sure that you keep those people focused on the bigger picture and the total cost of ownership of taking that in-house is really important. And again, that's, what's the consequence of us owning this? What is the opportunity cost? How many people are we going to have to spend in operations, both in their time, in the number of people, and so the trust is going to ebb and flow, but it should, be increasing over time. The cloud has weather, and this is the thing, right? It's today there was a potential IAM outage. I saw some people tweeting about it. I don't know that we experienced it. When you're on a hyperscale cloud provider, it's like asking, the status page is never helpful because the AWS status page is like, a weather report that just says whether it's sunny in Asia or not. For the answer to be no, things have to be very bad, right? It has to be cloudy over the entire thing. Although I just saw a news report that was yesterday, there was no rain anywhere in Australia for the first time in recorded history. So it does happen. It could be sunny everywhere. And so, personal health dashboard is a step towards addressing this, where you get, your local weather report. Is something affecting you individually? But understanding that, looking towards, Twitter is a great place to see if anyone else is being affected, because people will complain about whatever is hitting them. And when you're using services, right? So Lambda protects us against issues with EC2 and any AZ, right? But Lambda doesn't protect us against issues in Lambda itself. And Lambda says, I think it's either 4 nines or 99.95 SLA that they're offering, which is great. But then when you start to add up those SLAs across 30 services, the mean time between failure across all of them goes down a lot. And that's okay. Most of them are just minor hiccups. But it's important to understand that this is a consequence of the more services you're using, the more opportunities you're going to have to experience something. Now, I think this is, the next slide. So when you're experiencing something, the very first thing that you have to do is understand whether it's you or not. And this is probably the most difficult thing, because you need a smoking gun that you can point to for your CIO to say, this is a platform incident, not us. And therefore, the resolution of this is not something within the realm of our control. Now, once you do that, they're going to say, okay, well, I can, at least relax a little bit because I know what's happening. But you need to find that to guarantee it. We always look for feedback that we can give to AWS for ways that they can surface that better. Now, of course, even if it is, you still have work to do, because your system may not be reacting to those problems in the best way that it could. There could be things that you can tweak, especially if you have a Lambda that's invoking a downstream service that's having issues, whether it's because of you or because of the platform, and it's reading messages from SQS, you're going to want to turn that concurrency down so that the messages in your SQS queue, which should just sit there, they'll be fine. But if you don't turn the concurrency down, Lambda keeps reading from it, and all those messages will end up in the DL queue. And then you have to reprocess them manually. If you turn the concurrency down, then it will just stop reading. Now, of course, when the downstream is healthy again, you don't want to turn that concurrency all the way back up immediately, because then your Lambda will just happily start hammering the downstream thing even before it's healthy. We actually use Kinesis in a lot of places because not for the ordering specifically, but for the fact that the Lambda can just error out and the Kinesis queue will back up, and which isn't a property of SQS unless you're using FIFO. So we find that to be useful in some places to have that capability automatically. I think I covered most of this. This truth of, sure, you're frustrated. It's never not going to be uncomfortable to be in a situation where something is wrong and you can't fix it. Never feels good. And that doesn't it doesn't go away. It maybe gets better over time, but it never goes away. And so even just for yourself, maintaining that focus on, you wouldn't do a better job, right? When you look at how this works, if you between, say, Kinesis and Kafka, if you owned a Kafka cluster, it's a side business for you, right? There's something that your company does for its customers, and running Kafka is not it. And so this is something that your company is doing that's not a differentiator, that's not the primary thing. The amount that they're going to invest in it is just never going to be the level of somebody who's selling that as a service, right? Not only that, when you look at even for a SaaS provider, right, for Kinesis, the number of things that can go wrong in Kinesis that go wrong for however many, hundreds of thousands, millions of customers they have, happens on a daily basis. There's always, I'm sure, small things that customers don't even see go wrong. They get a lot of practice in how to keep that healthy. When you're running something yourself, you have incidents occasionally, hopefully not that often, and every time you get a little better at running it, but your learning rate is really, really low. Whereas if running a technology is what you're doing as a business at scale with lots of customers, you're going to see things a lot, and you will learn very quickly. And so that's why they're going to be better at it than you would be. So you let them be good at that, and then you can be good at what your company does. Biggest downside to serverless is that you only see what the provider tells you, right? For architecture, for security, for operations, right? You're limited to what that interface is. I think it's better over time, but there are things that can go wrong that you don't know about, right? And this is the known unknowns and unknown unknown. And then there's this final bullet of unknown unknowns, right? There are unknown unknowns inside the provider that you don't know about. And when that goes wrong, that's sort of the worst of all these cases. Now, so what you want to ask for is, how do I see better into these things, right? How do I have more metrics? How do I have more observability? How do I have more certifications? Right, certifications can help certain parts of your organization be more confident in it. White papers help, and then operationally asking for more metrics. You know, when we went live on AWS IoT, there were, it was like 8 metrics, and there was a lot of things that could go wrong, both in AWS IoT and in our use of AWS IoT, that could cause performance degradations that we wouldn't know about because there wasn't a metric that could tell us. There's only sort of far proxies of that in the app or in some other system that could show us where these things were happening. Now it's got, I don't know, it's like 100 metrics. Like it's a ton of stuff that you can see, and we can dive really deeply into our usage of AWS IoT to understand where it's going wrong, where we could improve things. All of that is important. And always keep, you know, one of the things about AWS in particular that I say, I was telling Kevin this earlier, never complain about AWS where they can't hear you. They take feedback very well. And so if you have an issue with something in AWS, something that you think could be better, something that you think is confusing, write it up. If you have support, send it to your account team. If you're on Twitter, hashtag AWS wishlist. Just make sure that they get that feedback somewhere so that it can be better. Because you won't make, you know, if you say something about it, eventually it gets better for me, and I like that. So staying current on AWS is basically a full-time job, but it's important because there are things that happen that you want to be able to make use of. Leverage your account team if you have enterprise support to get product roadmaps, to talk with product teams about what your needs are, how that can align with what they're doing. Now build it when you have to. So again, knowing, oh, in the next quarter, a feature is going to come out that's going to solve a problem for you. Do you need to ship that this quarter? Then you're going to have to build something for it. But maybe you can build it in a way that's going to be easier to replace by whatever's coming out. Or, what we found often is we build things like we built a custom resource for CloudFormation to integrate SQS with Lambda. And it just mostly just worked. And so it was about a year after the native integration launched, we finally transitioned over, and that was because we sort of found its one failure mode. But without that, it just works. So again, be pragmatic about, okay, well, the new shiny thing is out. And sure, we could switch, but is that a distraction from delivering the next feature? That's all I've got. I'm happy to take any questions. Yeah. Those things are great. They're so much fun.
Oh, okay.
Yeah.
Two questions. One is, did you use any sort of region-based failover? And second question, what kind of tools do you use to do CI and CD, actually?
Yeah, so we don't do region-based failover today. And the reason for that is the functionality we have, first of all, our uptime is good. And the importance of those cloud features to our customers relative to the uptime is, I think, in the right balance right now. If we were a security camera company, right, that calculus would change a lot, right? If you can't see, there's the guarantee that you provide to your customers is different there. We also have, in addition to good cloud uptime, if you're on the same network as your robot, the app connects directly over the network. And so if the cloud is out during that, customers may not even notice, right? So they're sort of, and the schedule lives on the robot. So if it's scheduled to clean, it will just clean. If you push the button on it, it's just going to clean. There's a lot of autonomy features that also sort of mitigate cloud outages for us. So today, it hasn't been important yet. At some point, it may become important. And at that point, I think that's when we would switch to that. Oh, CI/CD, yes. So it's a mix today of Jenkins and code build, code pipeline. We like code build, code pipeline, the combination. So we're switching off of Jenkins onto it. For quite a while, our very fancy, serverless native OLTP application was deployed from an on-prem Jenkins box. It's kind of a dirty little secret. But now that's an EC2 machine. So we like managed services. And that's also been a great story of where, the person who runs our build and tools team, first encountered code build, code pipeline, was like, I don't really get it yet. And I've got to put some fires out in Jenkins first. And then those fires got put out, things got stabilized a bit. And then the ability to look at, I can go from doing sysadmin work on Jenkins machines, right? Patching the OS, to providing these services to the development teams. And that's providing so much more value, and being then gung-ho about it, saying like, yes, let's figure out how to move there. I think is one of those stories about how you engage with people to evangelize serverless in an organization. So hopefully at some point that person will be able to tell their story publicly about how their interface with serverless. Anyone else? Grab the box, throw it.
Did you have any problems convincing your boss or whoever you need to convince to move from server to serverless? I mean, I know that you talked about scaling, but I'm sure you could have stayed with server application and scaled it.
Yeah, and so this is where we were very lucky. We didn't have a server application, right? We were just paying a company that had a service that did everything.
There's Key. What did you mention? What was that third company? It was a Key. Yeah, I remember. You mentioned a third-party vendor.
AWS IoT.
Oh, I'm sorry. Okay.
Kinesis, I think. Sumo Logic. They were a vendor for log ingestion and searching. Also serverless. You pay for the amount of traffic you send.
I think in the beginning of the presentation, you mentioned a company that was doing some of the back end for you.
Yeah, what
was the name of it?
A turnkey,
a turnkey. That's what it was called.
Turnkey as a descriptor of what they like. Yes.
Oh, I'm sorry. I was not familiar with. Sorry.
I mean, so it's just sort of the end-to-end thing. You just buy it off the shelf, and it does all the things that you're asking of it, right? And so that was SaaS, right? So it was all their systems, and they were, they worked primarily in the industrial IoT space, which has very different requirements for devices. In the industrial IoT, you have fewer devices, you have a lot more data, and you tend to have looser requirements on command and control latencies. Where in consumer IoT, you have lots of devices, but each one isn't sending that much data. And when the user presses clean in the app, you expect that to happen in short order on the device. And so it's just sort of a mismatch in the way they built their technologies. And so there wasn't really an option. I mean, they started building out to be able to scale, but it was just clear that it wasn't going to happen fast enough. It wasn't going to happen, the value that we were getting out of that platform wasn't high enough. So that's why we moved off. So we didn't have a server-based application that we had a process of convincing. It also means we don't have a baseline. Like, we can't say how much better it would be that we've done this than having run it, because we've never done that. I think, we were very fortunate in building this up greenfield and having a supportive organization that says, like, yeah, if it all sounds like a good idea.
Second question, if I can, if I may. Can you talk about some of the, what do you feed? You talked about metrics very, very quickly. Do you feed all your logs or your data into like ES, Kinesis, and then to like ES, or?
So it all goes into CloudWatch logs. And CloudWatch logs insights allows you to query across CloudWatch logs, and that's where we do a lot of that metricing, alarming, etc. Anyone else?
Question about, I'm not sure if this was a problem for you guys, but warm-up time for the Lambda, especially during that Christmas 4 hours, I can't recall what language or frameworks were you using, so it might not have been an issue if it was something like Go versus Java, but was that an issue? And do you have to get clever about like pre-warming the Lambdas?
So we're in Python, and another part about that partnership is that you talk with your account team about, this is what our expected sales volume, right? This is what our expected traffic is, so that they know and can communicate to the teams that you're relying on, this is the expected volume, pre-warm the things that you need to pre-warm. That's one part of the story, if you have the usage that justifies that. The other thing about cold starts in Lambda is you shouldn't start by worrying about them. What you should start is say, every cold start I'm going to treat as a 500 error, right? As like my user seeing an error. Am I still meeting my SLOs? Right? And the answer is almost certainly, right? There are definitely cases where cold start does matter, but they're kind of few and far between, right? The occasional cold start is the same as occasional network latency, right? There are random things that can happen that interrupt your user's experience. But if it's not, if your P99 is still fine, it's probably okay, right? So again, it's being pragmatic about how much does this actually impact my customers? How much value am I getting by spending time thinking about how to fix it? And of course, we expect that, there should be better tools, right? And so as people have been petitioning Lambda for, how do I get better at this? How do I just, pay for pre-warmed containers? Other questions? Sure.
Oh, I'm sorry. So you mentioned the team might be using code pipeline, right? So my question is around like, how do you actually go about best practices for local development purposes with the number of Lambdas you have? Do you use something like local stack or?
No.
Okay.
Very much not.
Okay.
So local development is not, the serverless future is not about local development. The serverless future is about better ways to do cloud-side development. And so we started out doing a lot of unit testing. So we used a library called Placebo for Python. It allows you to record and play back calls through the Python SDK. But we've moved away from that and rely much more heavily on integration tests. Because in the end, they're the ones that show you the thing you care most about, which is, what do your users see? And so it's much more about deploying the system, and then how do you get rapid iteration on the code that is deployed? And that depends on the developer. For some people, it's editing in the console. For some people, it's a download, re-upload loop, none of which are ideal developer experiences.
Yep.
But the TCO of it is the lowest. That's kind of the thing, right? And with local, it's one thing. So Stackery has a CLI that lets you sort of take the code that's remote, pull it down onto your local machine, and execute it locally. I think that's a decent model. But I think, yeah, we should be looking for ways, you know, with all of the cloud services that we use, there isn't anything that mocks all of them. And so if you limit yourself to only what's locally mocked, you're creating an artificial limitation on what your production system can look like based on what you want your development experience to be. And I think that's got it backwards.
Yep. Thanks.
Yeah.
Cool. Yeah, so hi, my name is Kevin Tuttle. I'm a software engineer here at Kyruus. I'm going to be giving a talk about sort of how we do CI/CD for serverless applications, and then also a little bit contrasting that a little bit with most of what you're able to find online as far as how to get started with serverless. There's a lot of getting started guides that will tell you how to create your first Lambda to resize images. It seems to be the favorite. But once you move from step one to actually wanting to go into production, and especially at an enterprise scale, you need to do something a little bit different. So, yeah, so if you go to the AWS website for Lambda and say, how do I get started with Lambda? It says step one, go to the console. So that works great when you're just starting out. It is a very easy way to sort of proof of concept to this. You can type code right there, you press the big or the bright orange save button, you press the test button, and it's very, very quickly able to sort of iterate and play around. For a day-to-day developer workflow, it's kind of a pain. If you want to create a subscription or like a trigger for SNS trigger, potentially for this Lambda, that's a different UI that you're doing multiple different clicks through. If you want to change some of the memory settings or maybe the role or the VPC, the timeouts, that's a whole bunch more clicks. You want to change the IAM policy, that's a whole other UI, a whole different area of AWS. And so very quickly, you're going all over the place. It's a whole lot of burden. It's very, very hard to make reproducible. If you want to, you could document this, but it's really going to be about a 200-page document of, okay, scroll here, and then anytime AWS changes their UI, you have to update that. So really, you don't want to do any of this. Once you've gotten past the, oh, this is cool, we should try to do this. You really want to be using a much more structured approach. So the tooling that we use is SAM, AWS Serverless Application Model. It's sort of a superset of CloudFormation. So rather than going around and doing a whole bunch of clicks to create a Lambda, really it's 2019, so you should really be using infrastructure as code. So for AWS, that means CloudFormation. If you wanted, you could use just pure vanilla CloudFormation. It's going to be a little bit wordy, so I would a lot more concise if you use SAM. They have some sort of macros to make things a little bit more concise. So here, this is the full configuration code for a Lambda that takes a SNS triggering event and is allowed to get and put objects from an SNet or an S3 bucket. So that's all described in, I don't know, 30 lines of code maybe, instead of having to go all over the place. And this is, yeah, much more reproducible. If something breaks, there's a single file to go to rather than 12 different UIs to go check. And then from a code perspective, rather than typing things into a text box in the AWS console, your programmers have their own opinionated, or very strong opinions about which text editor they want to use. You can let them continue to use those. And then all the code can just be stored in source control rather than in a console that you are constantly having to click an orange button to save. So you can write all your code in the text editor of your choice, go through the standards, pull requests, code review sort of process. And then another thing from a little bit more of a tactical standpoint, we found it's very useful to separate out the Lambda handler event parsing sort of logic into a separate file from the actual business logic. So here up near the top, you can see from app, import, do the business thing, logic thing. So that makes it really easy to swap out triggers as well. So there's been numerous times where we've decided, well, actually, we don't want an SNS trigger. We actually may be triggering this off of SQS, of a queue. And all we have to do is change this one file, and then the unit tests on this are really just making sure that the event parsing is the Lambda handler parses the event and then calls the business logic function with the correct values given the event. And for the business logic unit tests is also very simple because we're also sort of injecting all of the different clouds resource dependencies as well. So it's you have a lot less things to have to mock out. So yeah, and then local development. Yeah, certainly, as Ben said, you don't want to be doing sort of reproducing your entire infrastructure locally. We're trying to figure out how to do that. But certainly if you're developing a single Lambda, trying to make sure, run it, see that you're doing the expected output. SAM has a really nice command called SAM local invoke. Uses Docker locally, so you can run the code in the same basic environment that it will be running up in the cloud. Makes the cycle time really, really simple. So yeah, best practices. Don't be clicking around in the console. Have everything in source control. Have everything in infrastructure as code. Separate business logic from the event parsing logic. Makes the unit tests that you should write a lot simpler. We've also found it's really useful to include a sample event in a JSON file so that people can just, if they're going to be testing or making any sort of changes, there's already an event that's right there to use to invoke locally. Yeah, and then if you're in the AWS environment, then yeah, we recommend using SAM CLI, but there's certainly lots of other different options Serverless is the actual tool, is sort of a cloud agnostic one. There's also the GCP and Azure alternatives as well, if you're in one of those clouds. So then we've developed the application, we've built it, we've tested it locally. It's time to deploy. The AWS guide, we're using SAM now. The AWS guide has step 4, deploy your application to the cloud with this command called SAM deploy, which assumes that you are apparently have a developer sitting at their laptop deploying directly from their laptop to production, which maybe works out fine if you're a very early stage startup and don't have a whole lot of people and not a whole lot of governance, but certainly for a company of our size, working in pretty heavily regulated fields like healthcare, that's not going to fly. Yeah, don't do that. So we use code pipeline. At a very high level, there's 3 main phases to the pipeline: source, build, and deploy. So we use Bitbucket for our Git repositories. So there's actually no native integration between code pipeline and Bitbucket, even though there is a native integration between Bitbucket and code build. But so in order to get things from Bitbucket to code pipeline, we use a Bitbucket pipeline. For every merge to master, the Bitbucket pipeline zips everything up, sends it over to S3, and then that S3 drop is actually what triggers our code pipeline. So then the second step of the code pipeline is build, which we use code build for. So for when you're developing locally, you're just going to be having all the your source codes and dependencies. Lambda actually needs zip files with all the code that it needs zipped up nicely. So for Python, that's really just like a source file copy and pip install. Various other different things. If you're working in different languages, there's a SAM build commands that will work for a good number of different languages. I think that there's a whole GitHub project to improve that and add more support for different languages. But for most of the main flavors, I think that will probably work well for you. And then the AWS CloudFormation package command will actually sort of turn that local directory code URI in the templates into zip everything up from that directory, put it in S3, and then change the actual template so that it's pointing to that that S3 artifact. So that makes gives you a final CloudFormation template that you can just execute. And then this code build step is actually something that you can test locally. AWS released a code build local sort of Docker image and associated script. So this step won't really change too frequently, but when it does, you don't have to do the whole cycle time of uploading things, sending it all the way through the system up there. You can just test it locally, which has been so then deploy, everything is in SAM templates. So deployment is all handled by CloudFormation. As I said, we are very heavily regulated. We can't just have engineers just releasing stuff willy-nilly from their laptops. Every change to a production, any sort of production infrastructure change, including code or deleting or updating any sort of other artifact like an SNS topic or an S3 bucket, is subject to approval from one of the engineering managers. So rather than just tell people that, we actually enforce it. So there's a change set creation step. After that change set has been created, there's a manual approval step in code pipeline. When you get to that step, you have to enter in a Jira ticket name or key, and then which is the Jira ticket that is being associated with the release and is then approved by the manager. So then once you enter that in, there's a custom Lambda that retrieves that Jira ticket from Jira, the Jira API, actually validates that everything has been lined up and T's dotted or T's crossed and I's dotted. And then if everything checks out, then you're allowed to make a release. So I'll put all together. This is what the code pipeline looks like. The source, S3, code build step with code builds. Then there's a deploy to staging with creating a change set, and the manual approval process, that validation step that hits Jira, and then the execution of the change set, and then all four of those steps again, deploying to production. And then this whole pipeline is itself codified in a CloudFormation template. So it's very easy to stand up an entirely new code pipeline because it's all just right in the template. So then that was the sort of the standards flavor of the code pipeline, which for that most of our applications use, but there are a few different other flavors. We have a few standalone layers that aren't really associated directly with any Lambdas, having to do with like some of our log management and stuff. So we treat layer publishing sort of the same way you would treat a library version publish. So there's no staging environment, just deployed to production, and it's also not subject to the approval process because the change to production does not actually occur when the layer is published. It's when something is changed to use that new layer or that new version. So it's a little bit more of a abbreviated pipeline for that, and then for JavaScript applications being served up by CloudFront. There's the source is basically the same. The build is, rather than SAM build, is going to be using Webpack to sort of package everything up. And then the deploying stage is doesn't have anything to do with CloudFormation. It's really just copying things over into an S3 bucket that's then fronted by CloudFront. But it does still have the manual approval step in with associated Jira tickets. So from a high level, even if you're not using AWS or Code Pipeline, the things you want to be doing, looking for are making everything automated. You want to have the version that's being deployed reliant on a engineer being on the right local Git branch. You want everything to be sort of tied to that master branch in source control, and then triggered when that changes. And then if you have any sort of oversight process with your release, try to build that right in rather than relying on outside human processes. Questions?
In your model of deploying to a staging and production environment, you're validating. It looks like you validate your change set before something goes into that environment. How can you validate a feature has gone into that environment before it gets deployed?
So the approval is really this is the change that I want to make. The Jira ticket has a whole bunch of other stuff associated with it. Like this is actually the original user story associated with this code change that I want to make. This is the links to like the PR review process, and then this is the actual code that I want to release. So they're really evaluating on that. There is actually a development environment that is auto deployed to after that build step. I just sort of removed that for brevity, but.
How are we doing on time? 20 minutes? All right. We'll go a little more quickly. So hi, my name's Ben. I'm a principal engineer on our Patient 1 team. And this is going to be a little bit more in the weeds case study of our experience using SAM with API Gateway. The reason we chose it was because Kevin already did all this great work in building a deployment pipeline. So we just literally deployed a new pipeline to deploy our application. And what our application is, just real quick, is a patient search CRUD interface. So we get millions of patient records from our clients, and we have to search over them and then provide an interface to append records that are later processed by an analytics platform. So that was currently being mitigated by a couple different microservices that had been around for a really long time. And we took it as a good opportunity to say, hey, we can do this again, we can do it better, and we can do it with a much lower overhead for our infrastructure costs. So I'll talk about a couple things that came out of that and some of the problems and how we approached them. We went with SAM because that's was Kevin's deployment model. And what I think is cool about SAM is it's a lower cognitive overhead than a full-on API framework, but it's a little bit more than just an execution environment. So you're kind of left to your own devices and how you're going to organize your code, which I think is a good thing because you can choose patterns that your developers understand or choose portable options, whatever is applicable for your use case. So I want to talk about how you manage your code. And then for us, especially for patient team, PHI is a really, really big deal. And we have to adhere to an existing model that our other microservices use for authorization, as well as executing inside of a VPC because that's part of our security model. And if you've spent time in Lambda, you probably know about the dreaded cold boot times of private VPCs. So how are we going to deal with that? And then infrastructure as code, and Kevin touched on this. I think that's the really important bit and part of that serverless mindset that Ben talks about, getting our engineers to focus on how do you solve a business problem with a solution that you are getting from AWS as opposed to one you're building yourself. You don't want to build it yourself, and AWS is an ally in that regard. They're kind of doing a lot of work for us, which is really awesome. So here's just a quick, this is how I chose to organize our code for running an API. A lot of it is very similar. If you've been in Rails world or Django world, MVC, requests are coming in. The first thing that is sort of new is we've added this Lambda handler shim, and that goes back to what Kevin was saying. There's parsing logic that's going to be generic to API Gateway and Lambda that you don't want to mix in with your code because you might port it out. You might want to test not inside that Lambda context. So we pair those up with the actual, in this case, search patient, which is my normal controller code. That gets passed down into a general model repository object that then gets handled down to the database context. And the important bit here is that all of this is wrapped inside this cool green rectangle, and that's deployed as a Lambda layer. So if you're not already using the layers, they're very, very good abstraction for how to factor out common bits. It would be very, very easy to take that Lambda layer and deploy a completely different API on top of it that was doing different controller actions if you wanted to have that separation. It just gets imported just like a library into your code. Super simple. And I guess the only other thing I want to mention on this is also when you're talking about the database connection, I'm a database nerd. I just do Python because they pay me to do it. There's some cool implications about Lambdas and executing against database, and one of them is that the database context between two executions is completely isolated. Two executions of two different Lambdas. The same Lambda is going to happen sequentially, and if that Lambda is still warm, it's just going to keep doing the same job over and over again. So if you plan it out nicely, you can have a database singleton that's just sort of continuously churning. And in our case, you know, a couple of our routes are super high traffic, and most of them are, you know, lookups that happen very rarely. So there's some good optimizations to be had there if you're thinking about how to manage that context object. Yeah. And testability, there's a good testability story here again because you don't have to test against your inputs and outputs. You can, if you want, you can post JSON event posts to your Lambdas, or you can do some better context testing against your controllers. And Josh, so I guess to set Josh up, before this, the abstraction that exists in API Gateway is that there's an authorizer. All of that stuff is happening before this Lambda handler, so that's another benefit is your API can be processing against a context which you're defining. It's not necessarily, oh, what's their token? Is it still fresh? All that business. So Josh is going to give a quick rundown of how that works.
Yes, hello. I'm Joshua. I'm a software engineer here at Kyruus. I work closely with Ben on the patient team. And I'm just going to talk real briefly about using the API Gateway authorization feature, which is built around Lambdas. What's really nice about this is you can have a single authorization point that covers all of your routes. And instead of having to share having to write authorization code or put some sort of decorator on every single one of your route handlers, you can just have this, and API Gateway automatically will route all of the requests by this prior, saying like, wait, does this person have access? Does this person have permissions? Then you can append all of the user context you need and ship it off. So real quickly, so here's an overview of how we handle this. First, API Gateway checks for the authorization handler or header, goes ahead and passes that to the authorization Lambda. I should make that clear, as the authorizer itself is handled by a single Lambda or multiple Lambdas, depending on how you have everything configured. And then there, we're able to do all of our JWT verification, check that's not expired, check that wasn't issued in the future, use our JWT verification library to handle that. We retrieve our secret keys that we need to verify things from Secrets Manager, so that's all taken care of. We have a secure restore for that. And the surface area of having to do this business logic is really just isolated into this one API Gateway piece. Then we go ahead and we do a permissions check. I know some people use Cognito. We have an internal legacy user management service that we go ahead and go check in with. We say, is this user really a user? Also, do they have the permission they need to access the API? Do they have the various levels of permissions? As well as we can request a bunch of different information that the downstream Lambdas are going to need to process their own requests. And that information gets packed into a custom user context object that API Gateway will go ahead and pass to every single one of our consuming Lambdas. So that we already have all this information. We don't have to write in the consuming Lambdas, oh, let me go get that information again from the same user management service. So the last bit is that we go ahead and say, okay, based on their permissions, we'll issue this IAM policy, just like many of the IAM policies you see in AWS. They're highly flexible, so you can specify down to the route or even the set of routes or individual endpoints or everything, let's say, under, for us, like the patient route. So create, update, and delete, but nothing else. And then API Gateway will automatically handle the posting and will handle the issuing of like the denied, sort of the 403s and the 401s, based on the policy that you issue. So some of the interesting sort of benefits that we found in setting this up, again, single point for authentication. You can also have multiple Lambdas, or you can have different authorizers for different Lambdas if you need that kind of flexibility. Again, the IAM policy is incredibly flexible with what you can specify. The other thing is that API Gateway has built-in caching for this user information. So you just set the amount of time you want your cache to live for. Tell it which key you're keying the cache off of, and it'll go ahead and save that user context and authorization information for that period. That way you're not continuously re-triggering your authorization Lambda every time you hit a specific route. And instead it'll go ahead and turn over automatically. You don't have to set up any Elastic cache or anything. It's a built-in feature in API Gateway, very low overhead management. We did find a few pitfalls. One, if anyone has experience working with front end and trying to talk to APIs, CORS is a big issue. It's always a big headache. What the browser does is it sends an options pre-flight request. And API Gateway is still kind of under development, I think, so they have it. So by default, the authorization will be put in front of the options request for that particular endpoint. Usually can't send a token with your pre-flight request. So you'll have to do a little bit of configuration, set up. What our solution to it was to set up a options Lambda handler that just issues a pre-configured set of CORS headers to the user, and we have it configured to not be behind an authorizer at all. And the other trick is that you have to be careful with your IAM policies because they do stick around till that cache expires. So if your user changes their permissions, you need to either manually bust that cache, there is an API endpoint for it, or issue a new key. In our case, we key off the JWT, or do some sort of other cache busting, or just wait for it to expire. And the authorizer is also not supported locally when we're using it with SAM. So right now we do have that upload to AWS, test it, try it again, sort of cycle. But that's definitely not that big of an issue. And you can actually test, we do have unit tests for authorizer locally, so we can mock a lot of that out and make sure that our authentication scheme works well. So I'm going to pass it back over to Ben to finish us off.
Yeah, so, API Gateway, the abstractions are under development, and the benefit is there's cool new stuff coming out all the time. I think they do have an abstraction for the CORS bit now as well. And I just want to highlight this this piece of it. We have to run everything inside of a VPC. We have to reckon with the cold starts. But the beauty of a lot of these abstractions is they build in all of that stuff. So it's super simple. This is, I don't know, it's 12 lines of code that execute all of our Lambdas privately, and then additionally scope the API just to a single VPC, which is our VPN. So that's privately networked. It's just very cool. This used to take a lot of jury rigging to get everything deployed into the right environment. And all you're doing here is just saying, if it's not coming from that VPN, don't let it in. The caveat here is that this syntax came out in October. So before that time, there was a lot of jury rigging involved. So it's, again, I think best practice is definitely to get on GitHub on the serverless application model and the CLI and track issues, because people are asking for these things, and it's totally, in my observation, it's totally demand-based. It's not necessarily AWS wants to be more pure of a programming abstraction or something. They want to satisfy people's needs. So if the issues exist, and probably you'll run into ones that are open tickets, vote them up and get action on them, because they'll give you this nice syntax if you do. And then the other sort of tangential benefit out of all this is that we can now build any sort of feature branch we want, whenever we want. It deploys the entire stack. It deploys the VPC, the gateway, all the Lambdas, a database. it provisions some secrets, it networks them all together, seeds your data, and then reports back the URL so you can go test it. So hooking up integration testing to that is dead simple. And it doesn't, it's a free benefit out of doing all this parameterization and the infrastructure as code from the get-go. And since your developers are also now doing infrastructure, it's kind of essential because you need to test these infrastructure changes. So you got to deploy. And then our application specifically is heavily configuration based. So that's another benefit for us is you can spin up a database, do a bunch of crazy stuff, test it out, and then your horrible mess is cleaned up after you. So takeaways in our experience is, do allow your developers to manage their own infrastructure because then they can use services to solve their problems instead of writing Python scripts. Do feature branch deploys because you basically get them for free. Write your code in a portable way. We have a bunch of places where we can break in for unit testing, for functional testing, for whatever kind of testing you want. And that's been really, I think, a big sea change for us from what our old multiple microservice interaction was. This is my own bit because I'm a Postgres nerd. It's okay to use a conventional database. I think a lot of people will tell you use Dynamo, and there's really a lot of good reasons too because they've abstracted away that connection problem, but it's manageable. And if you are hamstrung to some old database, that doesn't mean you can't do serverless. You're going to have to instrument it appropriately, but that's totally okay, and I think it's cool. And don't forget, there is a 200 resource limit in your CloudFormation templates. You will get bitten by that sooner or later. And also, the serverless API abstraction in SAM is probably the one that's under the most active development right now. So it's got a lot of really great features in it, but if you try to trick it to do things that it doesn't want to do, you might run into problems because it's changing a lot. And, we jump through hoops in order to do a lot of private networking to manage our VPN connections. If you could avoid that, your life will be much easier. We can't, we're healthcare. So yeah, any questions for Josh or myself?
You mentioned you're using a conventional database like Postgres is. You suggest using that. They have managed services that talk PostgreSQL. Do you have any guidance or recommendations about when to choose that or when not to?
I think for us, the thing we're sensitive to is the connection limit. You can't guarantee, how many connections you're going to be creating. Each one of our Lambdas is going to create its own connection to the database right now. And we're talking to the legacy database at this point, so we don't really have a choice in changing it up. I'm not sure what the story is with Aurora and other things like that, but I would say if you are concerned about the spikes in your scale, load balancing or some bespoke tool that abstracts away that connection might be a good solution for you.
Great. The other question was based on that. Do you happen to know if that 200 resource limit in CloudFormation also applies if you have subtemplates?
No, it does. Well, it applies to each subtemplate, but you can have, somebody figured it out recently, I don't remember. You can have some number of subtemplates, a lot.
And have you considered, I guess, the follow-on, componentizing your infrastructure that way through templates as opposed to writing huge CloudFormation templates?
That's exactly what we're working on right now. Yeah. The benefit is our API really ends up being like 4 routes, so the template's not that huge. Get the box.
Can't really touch it.
That's the whole point. It's fun.
It is. It's really fun. Do you have all those routes in one Lambda, or do you split out the routes into separate Lambdas?
Each route, each verb has its own Lambda as it exists right now.
Second question, you have this common code in a layer. Mm-hmm. Why not, what language do you write in?
Python.
So why not an internal PyPy to share that between different uses of the code?
Yeah. We have a history of sharing libraries that I think has not always rewarded us. So, but you're totally right. That's an option. We're pretty new into this process, so that's definitely one of the routes we could go.
Okay.
Anyone else?
This was from the previous presentation as well, but if I heard that correctly, it seemed like this layer for the Lambda didn't require as many approvals, and it was more like because we don't really deploy it immediately, then we just don't require approvals. How do you tie that into, actually everyone is using that layer, so how do you validate that you actually get approvals for getting that out there and not surprise anyone with an in-flight deployment?
Yeah, that's a good question. For us, we are packaging our layer with our repository. So at the end of the day, when we talk about the patient API, it's the Lambdas, the API gateway, and our particular version of that layer. Personally, I think I would like to see more variability, and if somebody else was choosing to use that layer or share that layer between us, then they can, I don't know, I like the model more of forking it than importing a library personally. But right now, the way that application looks, the layer is right there with the code, with all of the controller code and the Lambda code. So each API is its own self-sufficient application.
But that one, the authentication one, is that not part of the? Oh no, that went into the API gateway, not the Lambda layer, right?
Right.
Okay.
Yeah. Right now, actually, the authorizer code is all the same, but the cool part about that is that at the end of the day, you're issuing a user context, which can be whatever you want. So if you agree with the other API developers on what sort of user context objects your applications are going to handle, that authorizer can be completely agnostic to what API it's being imported with.
Thanks.
And that the user context is so cool, I personally think, because you've completely gotten out of the process of having to go through parsing and importing JWT libraries and all that other dumb stuff, and it appears in your logs as part of the event that triggered the API action.
Is that passing the headers somewhere?
It's just a JSON blob, so it's really literally passing whatever you want to pass out. So basically anything that you could surmise from your JWT token, and in our case, we're actually talking to a customer service API, asking it for some additional information, we can wrap that up all into a nice blob of whatever we want. And that's probably one of the best parts we're putting serverless into a microservice architecture of this entire company, and it's a nice way that it's able to play nicely without breaking the world or making some ridiculous requirements about how JWTs are handled.
Cool. Thanks.
Yeah.
Kyruus and AWS, Google Cloud, Progress, our sponsors, and thank you for all coming. I think we have a few minutes if you have questions and you want to chat. We officially end at 6:30, which gives a few more minutes. If you want to talk to me about MassTLC or any program ideas, please do so. I am going to be sending out a survey about this tomorrow too. We really, really value your feedback as we're building all of these programs, topics, times, locations, all of it. So thank you very much.